Well, our discussion is regarding the system of particles and the rotational motion. So, in the system of particles, basically, we consider a solid. That solid can be in the form of a sphere, a cube, a cuboid, or of any other shape. Another thing which is important about that solid is that solid is made up of atoms and molecules, that is the particles. So when we use the term that the solid is made up of particle, normally we are saying that they are made up of atoms and molecules. Moreover, in the whole volume of that solid, we find that there are plenty of particles. It is found by experiments that if the amount of solid is just about 1 gram, there are about 10 to the power 20 atoms in that particular solid. So we can calculate it by using a mole concept, and from that we can estimate the number of particles or the number of atoms or molecules in that solid. Now, another important thing about the solid is that the particles are very closely arranged in 3 dimensions. That is, the whole solid is made up of the atoms, and those atoms are adjusted on the axis, that is x-axis, the y-axis and z-axis, and the distance between every two atoms on any of the three axes is called the lattice parameter, and the axes are known as the lattices. Now, the separation among every two atoms on any of the three axes is nearly 1 angstrom unit. They are dominated by certain forces, and those forces are called the interatomic forces among the atoms in 3 dimensions. And these interatomic forces are responsible for binding the particles in the solid. Moreover, if the whole solid have a translational motion, then the particles of that solid will also have the translational motion, but they will remain at their significant places. Now, if the whole solid is rotating, then the particles will also rotate about their individual axis. Now, these facts what we have to go through in the system of particles. Every particle or every atom has got a mass like m1, m2, m3 and so on up to mi. Mi means the mass of the ith particle, and all of them have got some position vector like r1, r2, r3 and so on up to ri. So whatever concept I have just explained, the same things are to be discussed in the coming portion. So first of all, we come to the definition of rigid body. Rigid means having a definite shape, that is unchanging shape, and it will be known as a body with a perfectly definite and unchanging shape is called a rigid body. The distance between all the pair of particles of such a body do not change. This distance is called the interatomic distance, and the force between these two particles is supposed to be interatomic force, which is attractive in nature. So many forces are acting on these particles, but still we don't find any change in the position of particles in a rigid body. Another thing we find the motion of a rigid body will be of different kinds, like rotational, like translational. So we find that, like for example, in a given diagram, there is a wooden block, and P1, P2 are the particles of that block. We are finding if there are translation motion in the block, then P1, P2 will also have the same velocity as that of the block. So it is sliding down the plane. Now, what is pure translational motion? When we use the term pure translational motion, it means that the translational motion at any instant of time all the particles of the body have the same velocity, as I have just now explained in the case of inclined plane. Translational or sliding motion of the block down the inclined plane, any point like P1 or P2 of the block move with the same velocity at any instant of time. Therefore, whatsoever is the velocity of the block, same will be the velocity of the particles of that block. We have selected the particles in the form of P1 and P2. So again, the figure is being shown. There is a block and that block is made up of many particles. We have selected the particle like P1 and P2. There will be a lot of particles like P1, P2, P3, P4, right up till Pn. It is made up of n particles. Whatsoever is the velocity of the sliding block, same will be the velocity of all the particles at that instant of time. Now we come towards the pure rotational motion. Suppose that the whole body is rotating about its own axis. Now that body is made up of atoms or molecules. The distances among the atoms are generally 1 angstrom unit, that is called lattice parameter. The axes on which the atoms are arranged are called the lattices, and the distance is called the lattice parameter. A rigid body fixed at one point or along a line can have only rotational motion. Then when the body is moving about the axis, all the particles of that body or all the atoms of that body are in rotation. Whatever is the rotational speed of the whole body, same will be the rotational speed of the individual particles. So this fact now we have to go through. In rotation about a fixed axis, every particle of the rigid body moves in a circle which lies in the plane perpendicular to the axis and has its center on the axis. Every point on the rotating body has the same angular velocity at any instant of time. So this is clear from the figure that the whole body is moving along the z-axis. The three axes are indicated. We have selected C1 and C2 as the center of mass of the body, or P1 and P2 are the particles of that whole body. C1, C2 are the center of masses, and R1, R2 are the position vectors. The whole body is spinning as indicated on z-axis in the anti-clockwise direction. So the particles are also moving in the anti-clockwise direction, but they will not leave their position. So what is pure rotational motion? A rigid body fixed at one point or along a line can have only rotational motion. In rotation about the fixed axis, every particle of the rigid body moves in a circle which lies on the plane perpendicular to the axis and has its center on the axis. Every point on the rotating body has the same angular velocity at an instant of time. A rigid body rotation about the z-axis, each point of the body, such as P1 or P2, describe a circle with its center C1 or C2 on the axis. This I have just now discussed, that whatsoever is the speed of rotation of the whole body, same will be the speed of rotation of P1 and P2. And C1, C2 are the center of masses of P1 and P2, and R1, R2 are the position vectors. So radius of circle R1 or R2 is perpendicular distance of the point P1 or P2 from the axis. A point on the axis like P3 remains stationary. Now again, it is clear from this given figure, and whenever we take the body, we always take it in the three dimensions. So a point other than origin will have three coordinates, the x, y, z coordinates. Now we are referring to spinning. So what exactly is the meaning of spinning? that is, the body is moving about its own axis. If the axis moves around the vertical, spinning means axis itself is moving around the vertical through its point of contact with the ground, sweeping out a cone, then motion is called spinning. This movement of the top around the vertical is termed precession. Now we can just see here a top is spinning about its own axis, and the point about which the axis is moving is origin, that is O, and the spin is considered in three dimensions, the x, y, and z directions. So we have taken the cone in the form of a spinning. C is the center of mass of the cone. A spinning top, the point of contact of the top with the ground, its tip O is fixed. So tip will be fixed. But when the whole top is moving at a certain angle or spinning at a certain angle, all particles, all atoms of that top are spinning about their axis. Now we come towards the rolling motion. For that, what we do is we consider an inclined plane and we take a wooden ball and it is made to fall from the plane. We will find that it is in a straight line motion, but it is rolling on the plane. So rigid body having translational motion with the rotational motion is called rolling motion. If the contact point is at rest with respect to surface, then motion is said to be pure rolling, otherwise rolling with slipping. So ball is when allowed to move on the plane of inclined plane, it is rolling along with slipping. Now this is indicated in the diagram, and omega is indicating the angular speed, and when the particle is at P1, its velocity is indicated by drawing a tangent at that point, and that is V1. Same is the interpretation for V1, V2, the particles P2, and the position vector is taken as R2 for the particle P2. So position vector for particle P1 we can take as R1. Now when we write VCM, that means the velocity of the center of mass. C represents the center of mass of the body. The rolling motion without slipping. If slipping is not there, but the body is rolling. So rolling motion without slipping of a disc on a level surface. So what we have to note? Note at any instant the point of contact P0 of the disc with surfaces at rest. That is in the previous figure, we have gone through with it. The center of mass of the disc moves with velocity VCM. VCM stands for velocity of the center of mass. The disc rotates with angular velocity omega about its axis, which passes through the center of mass C of the whole body. The center of mass, velocity of the center of mass is r omega, where r is the radius and omega is v over r, or omega can be taken in terms of time, that is 2 pi by t.